Hello and welcome everyone. In this lecture, we will discuss about the balancing machines. So basically, the machine which determine whether a rotating part is completely balanced or not, we called it a balancing machine. So if there is unbalance, then the balancing machine are used to measure the magnitude and direction of the unbalance. Some of the balancing machine only measure the static unbalance and some of measure only dynamic unbalance, while there are some machines which are capable of measuring both type of unbalance, static and dynamic. So based on that, the balancing machine are classified in two types. First one is static balancing and dynamic balancing. So the static balancing involves the balancing machine used for measurement and correction of unbalanced part in which are related to thin in axial directions such as flywheel, pulley, gear, wheel, narrow fans, in which it is the possibility of dynamic unbalance in practically negligible. So for static balancing, there are two balancing machines: gravity type static balancing and oscillating type balancing static balancing, that we will discuss in the next. So first, the static balancing. Let us discuss about the gravity type static balancing. As we can see in the figure, the working of such static balancing is similar to our weighing machine. The rotating part which is to be balanced is mounted over on the mandrel. This is our mandrel, and then the mandrel is supported to one end of arm of the balancing machine. The dead weight W is suspended on the other end of the arm in order to bring the arm in horizontal direction. Now the mandrel is rotated slowly. Now we will rotate this mandrel slowly. So by hand or by a right weight part or by electric motor in case of heavy part. If the part is unbalanced, then the arm will move. This arm will move up direction or will move in up direction or in down direction according to the pointer fixed to the arm will move across the scale. This pointer will move across the arm and thus calibrated. It can be calibrated in any unit. Generally the unit is kg into centimeter or kg into meter. This is the general unit which we know that the centrifugal force or the which measures the force kg into meter. Okay, so if the part is in static balance, the pointer will remain in the stationary. There will be no up and down movement, which means the scale will not move in any direction. This will be at this position if the part is completely balanced. Next is oscillating type static balancing. The figure shows the oscillating type static balancing machine. Here in oscillating type, the part which is to be balanced is coupled to motor and both are placed on cradle. Here this is our cradle and this is our part to be balanced and which is coupled with the motor. What will happen? The cradle is supported by two pivots P and two compression spring. We can see from the side view there are two compression spring 1 and 2, and in horizontal direction there are two pivot P1 and P2, such that even a small unbalanced static force will produce large oscillations or vibration of the cradle about the pivot. If the part is statically balanced but dynamically unbalanced, then the no oscillation of the cradle will take place. As this is the only static balancing machine, so we cannot find the dynamic unbalance. So as there will be the when we start the motor, if there is unbalance existing, the uh, cradle will oscillate about this pivot point. So this is oscillating time static balancing machine, and the last one is dynamic balancing machine. In case of rotating part having considerable width in axial direction, such as turbine rotors, motor armature, they are having considerable direction in width in axial direction. So the unbalanced centrifugal force produces unbalanced couple, and hence dynamic balancing is very important. The purpose of dynamic balancing is to measure the unbalanced couple and introduce a new couple of same magnitude but in opposite direction. The new couple is introduced by adding extra mass of same magnitude or extra mass on two pre-selected plane, or by removal of mass by drilling holes in plate. As we can see in the figure, there is a pivoted cradle type dynamic machine. In static we discuss only cradle type static balancing. Here there is a pivoted cradle type dynamic balancing machine. The part which is to be balanced is mounted on cradle with the help of half bearing or supporting roller. Here it is mounted on the cradle with the supporting roller and half bearing. Now the one end of the part is connected to the motor through universal or Hooks joints universal coupling. Now the cradle can be allowed to rock or oscillate about either of two pivot. There is two pivot over here. The cradle is allowed to oscillate about this two pivot, which can be adjusted to coincide with the correction plane on the part to be balanced. Now the left pivot is in released position. This is in the released position, and the right pivot is in locked position, so as to allow the cradle and the part to rock or oscillate. This can rock or oscillate. At the both end of the cradle, the spring and dashpot are attached. Which are adjustable so that the natural frequency can be adjusted and made equal to the motor speed. Now the two amplitude indicator are attached at the each end of the cradle, left amplitude indicator and right amplitude indicator. These are called as velocity type vibration pickups. These are used for the unbalanced measurement. The permanent magnet is mounted on the cradle, which moves relative to stationary coil. Here there is a permanent magnet, and this is our stationary coil, and generates a voltage which is proportional to the unbalanced couple. This voltage is amplified and read from the voltmeter, which is calibrated in kg into centimeter or kg into meter. When the right hand pivot is locked, the unbalance is in left correction plane will cause vibration whose amplitude is measured by the left amplitude indicator. After the left pivot is locked, and another set of measurement is made for the right hand correction plane using the amplitude indicator on the right hand. So for the second reading we will release this, and we will lock the first left pivot, and we will measure same for the right side amplitude indicator. So this is it for today's lecture. Thank you very much for watching.